this video, we are going to continue with revision exercise 13. You will find this on page 571 in the Namibian AS-Level Mathematics textbook, Y equals mx+c to success. In the previous video, we did number 1 and 2, and in part 2, we're going to do number 3 and 4. I'm just going to show you. There is 3, so you can pause the video and you can do it. It just continue on this page. So there's the rest of 3, and then there is 4. Okay, again, my advice is that you first stop the video, you try to do it on your own, and then you continue the video to see if you're correct. But let's start with number 3. The diagram shows the curve y is equal to x squared cos x, and x is bigger and equal to 0 and smaller and equal to a half pi. Okay, and its maximum point, so it's a stationary point, is m. Show by differentiation that the x-coordinate, that means the x-coordinate of m, satisfy the equation. Okay, so first, as soon as I talk about the stationary point, I must first go and differentiate that equation. So I'm going to say dy, and that's number A, dy over dx is equal, okay, and remember, I rewrite the first one and I differentiate the second one. And then plus, I rewrite the second one and I differentiate the first one. And then I'm going to do it, so it's going to be x squared, and then it's going to be negative sin x plus cos x, and if I differentiate that one, 2x. Okay, so it's negative x squared sin x plus, put that in front. Please don't multiply, that's a unit, it's nothing, so please don't make that unnecessary mistakes. Okay, cos x. Now, you say at the stationary point, dy over dx is equal to 0. So therefore, in the place of dy over dx, I'm going to put a 0. Okay, and now basically I'm just going to take this over, and that's going to be equal to 2x cos x. Now I think first let's get rid of that extra x, and remember it's this one that cancels. So I end up with x sin x is equal to 2 cos x. Okay. Now, if I'm going to divide, I'm dividing by cos x, and I divide by cos x. And the reason why is because I want tan. Always let that lead you. So I end up then with x, and then I end up with tan x, and that is equal to 2. Okay, but then I just want to still get tan x alone. So I divide by x, and therefore tan x is equal to 2 over x, and that's number A. Okay, I'm going to have to go to the next page to do number B, so let's just continue. This is number B. Verify by calculation that this equation has a root between 1 and 1.2. Now, don't forget, from the previous page, we had, I'm just going to write it here, I'm just going to move it a little bit down, and then I'm going to write tan, remember that's from the previous page. Now, can you remember, and this is very important, if it's the small f, x, I just take everything to one side. So take that to that side. So I'm having then tan x minus 2 over x. Okay. Then I'm going to substitute 1. So it's going to be tan 1 minus 2 over 1. And if I press it on my calculator, I get negative 0.443. Just take note, it's a negative value. And then I substitute 1.2, exactly the same. So it's tan 1.2 equals 2, not equals, let's just subtract, look always at the original, otherwise you can make mistakes. 2 divide 1.2, and if I press that on my calculator, I get 0.905, and take note, that is positive. And then I say, therefore, the change of sign indicates the presence of a root between x is 1.0 and x is 1.2. And that was number B. And then I go to number C. Use the iterator formula, okay, there to determine this root, correct to 2 decimal places, give the results of each iteration to 4 decimal places. Okay, now you know that the root is there. So I can then go and I can start with x1 in the middle. Okay, make it 1.1. So x1 equals 1.1. Okay, and then I'm going to say, oh, I made it so high there. It looks almost like an exponent. 1.1. And then my formula is going to be x n plus 1 is equal to, okay, remember that's fx capital, is equal to tan, that means the angle, by inverse, and it's 2, and that's the negative 1, negative 1, negative 1, okay, and it's 2 over xn, okay. Now, I'm going to press on my calculator, now I'm going to get 2. So take your calculator and press 1.1 equals. It's in your memory. And now press shift. That means shift the angle, tan. Make sure your calculator is on radians. And then bracket 2 divide answer, close the bracket, equals. And I get 1 point, and remember it's 4 decimal places, so 1.06. Okay, and that is going to, because of the 795, it's going to be 8, and put the 0. It's 4 decimal places. If I approximate it, it's 1.07. Okay, and then I get x3. Press equal. And it's 1.0803. And then if I approximate it, it's 1.08. And then x4, oh, let's just get it correct. And that is going to be 1.0755. And if I approximate it, it's 1.08. And then I just end, but this is a very nice question. So therefore, correct to 2 decimal places. X is equal to 1.08. And that's how you do number 3. Let's do the final one. This is a nice feeling. It's the final one of the last chapter. Okay, let's just make space. Okay, let's start with number 4. Just want to go up a little bit to have space. Okay, so number 4. The diagram shows the curve. Y is equal to E, and that's to the power, if you make it bigger, and in your textbook, you must have a textbook also, negative to the power x. And I already told you, you can check the local bookshops but you can also check. The books are also now available at Walton's, where there's a lot of bookshops in the country. Okay. So let's just go a little bit smaller. Okay. Then I'm going to start. They say, the shaded region R is bounded by the curve, the lines y, remember, you just make it red, y is equal to 1, and this is P, okay, where P is a constant. Okay, find the area of the region R in terms of P. Now, I'm going to show you two ways, and both is correct. I'm first going to show you, can you remember, to find the area between a line and a curve. I'm directly going to show you this method. And then I will show you the other method where I will work out the area of the rectangle and then subtract that to get R. But I want to show you that you get the same answer. But let's start with the one, okay? And the one I want to start with is the area between a line and the curve. Now, what is that line? Oh, sorry, I just want to go a little bit. The line is y equals, I don't know why is the problem with my colors now. Y is equal to 1. And the curve is going to be y is equal to e to the power negative x. So if I want to find the area, let's just go area of R. And then it's between P and 0. Okay, now which one is on top? That is on top. So that's why I say 1 minus e to the power negative x. And remember, I integrate to x. Always if you see area, integration. If you see gradient of a curve, differentiation. Okay, so now I'm just going to integrate. So this is a constant, so it's x. This one, I'm just bringing that negative down, okay? It's actually 1 over negative 1, but it's negative 1. And then e, negative x, and it's p and 0. Okay. Now, I'm just going to say, so it's e plus e, negative x. I just simplify it a little bit. And now I'm just going to substitute. So, in the place of, it's going to be p plus, and now I'm just going to substitute that one also, e, negative p, okay, so that's the first one, subtract, and then I substitute 0 plus, and then e, negative 0, and I close, okay. And then I'm just going to quickly simplify this, so this is p plus e, negative p. Now, just remember, this becomes plus 1, because anything to the power of 0 is 1. And a negative times that positive, so it's negative 1. That is how I do it directly. But I also want to show you, and I want to show you also, in the teacher's guide, it's done like this. So if I want to find the area of the shaded, I can say area of shaded, I can also say the area of the rectangle, just want to move it a little bit, minus area under curve. Okay, can I just show you on the picture again? I just want to show you. So basically what I'm doing, I'm going to work out this area, and then I'm going to work out this area. I subtract that, and then I will be left with that area. Okay, so let's do it. So what is the area of the rectangle? And I have to go back again, because this, don't forget, that is P, and that is 1. And the area of a rectangle is just length times breadth. So it's just length times breadth, okay, which is just going to be P times 1, okay. And now I'm still going to, now it's just under the curve. So the line is not having an influence now. So now it's just going to be still, and it's P and 0, and now I can just take the curve. because it's under the curve, not the top. Okay, so it's negative. Okay, my lines is just not good there. If I integrate, so it's negative 1 e negative x. Okay, there it is. And then it's p and 0. And then it's going to be p minus, okay, let's just keep that bracket. So it's negative e, and then I subtract the p minus, okay, negative e negative 0. And if I simplify this, I'm getting p, okay, a negative times a negative is positive e negative p. Okay, now just be careful here. This is going to become negative. Okay, I just want to take another color. This is negative, and then it's negative 1, because that is going to become 1. So that is going to become positive times that negative, so it's negative 1. And if you check, it's exactly the same as you got there. So it doesn't matter. Please don't do both. only do one in the exams. Okay, and then number B. Number B. Show that the area of R is equal. Show that if the area of R is equal to 1, then. So if I go and I say the area of 1. So remember, this is now number B. Let's just take another color. Area of shaded. Don't forget, it's now this P plus E negative P minus 1. And I tell you it's 1. Okay, and let's take that one over. Okay, so basically, I'm just going to have 1 plus 1, so it's 2, minus, and then I take this one also over, E minus P, and that's P. So, therefore, P is equal to 2 minus E negative P. Okay, and now I go for that chapter 13, why we are doing this. So we were just, again, doing other chapters. Now we come to this chapter's work. And I'm just going to do it on the side here. So this is now number C. Let's just see what is the question of C again. Use the iterator formula. That's the formula I got. With initial value P1 is 2, that's very nice, they tell me P1 is 2. To calculate the values of P, correct to 2 decimal places, that's the final, but give the results of each iteration to 4 decimal places. Okay. So we're just going to write that formula down. Remember, it's now not X, just P, doesn't matter. And it's 2 minus E. And that is going to be, oh, it's just very, very small. I just want to show you. It's very small. So in the textbook, I think you will see it better. But it's negative P to the power N. Do you see that? Okay, let's just go. Okay. So let's just write it down there. And that is just going to be to that negative P, and that's N. And remember, that's Fp, not Fx, because it's in terms of P. Okay, so let's just take that calculator and program the 2. So press 2 equals. And now start. Say 2 minus, and I must press Shift Lin to get that E, but it's actually E. And then I put a bracket. And then it's negative. The answer, close the bracket, equals. And I get, it's 1.8647. And if I go to 2 decimal places, it's 1.86. P3, but press equal, and it's 1.845. 1, and if I approximate it, 1.85. And then I go for P4, so press the equal, so it's 1.84, and then it will be 20 because of that 898. to 0. And if I approximate, please remember that 0. If I approximate, it's 1.84. Then I go for my P5, press the equal, and it's 1.8415. And if I approximate, it's 1. And as soon as I see two consecutive numbers are the same, I stop and I say, I just end. Therefore, I want to go to red. Therefore, correct to 2 decimal places, P is equal to 1.84. And that's how you do it.